Okay, hi, hello YouTube, and welcome to my new tutorial series. I'm working on a project lately, so I need to build a 3D city on a web platform without using any map services like Mapbox or Google Map, those sort of things. So, as you know, map servers, they're like, they're compounded products. So basically you don't have copyright for the data, and you can't change the data as well, and you can't change any of its functionalities, so sometimes it could be expensive as well. So if you develop something for the business, or for example schools, or your project require you have full access and full copyright of the, maybe not of copyright, but you need to change the data and you have full control of the data, then it's not going to work. So today I'm going to teach you how to build a 3D city on the web platform by using Three.js and completely free data sets. So, well, basically you need to have some basic understanding of JavaScript and HTML, and also I'm going to use the modern front-end developing framework as well, but it doesn't really matter whatever you use, whatever Vue.js or React.js or just vanilla.js, they all work as well. So as you see, this is the example, and yeah, so I'm gonna create a new project by using Vue CLI. As again, you don't really need to use Vue or any like Webpack related developing tools. You can just use HTML and JavaScript. I will also give you an example of how to just use the static HTML to build these things. So just create a project called YouTube, and right. So when it's been creating the project, I also introduce you Three.js as well. It's a web 3D platform, not a platform actually, or I should call it engines actually. It's a 3D engines, and you can use it to modeling, well, to build a 3D space on web platforms. There's a lot of this example here, and they have a very detailed document as well. It's very popular, and companies like Google's are using it as well. And well, it's probably, you don't have much choices when you engage in this. If you want to build a 3D things on the website. So yeah, that's one of the choices you can use. And there are other, I think there's other platforms or frameworks names, Babylons, right? You can use that as well, but today I'm just going to use Three.js. So the Three.js, unlike the other 3D gaming engines, it doesn't have any GUI editor for you. So basically you need to write every line of code by yourself, and that could be a bit tricky, but well, if you follow me, and by the end of the video you can make 3D city as well. And for the map part, I'm going to use OpenStreetMap data. So basically it's a completely free map data sets, and we widely used for by a lot of different map servers as well. And as long as you contributed them, just write down it's the data coming from the OpenStreetMap, it's totally fine. And those data are you can legally copy them, distribute them, and transmit them. And also we can make changes as well. But you can only distribute them under the same license, so you have to make it free again. Right, and okay, let's get started. Right, so I have successfully created this project by using Vue of developing tools. But as I say, you don't need to use this one. Basically, this is my workspace. In the Vue that they have a set structure, so I'm gonna write the code styled in the Vue style, but you don't really need to follow this one. Just remember, this data is, you can understand it as a global data. Well, it's still private for this file, but it's global data. I'm gonna write up all the global variables in here, and also all the functions here. And this is the initial functions in the Vue life cycle. So it's the first function called. That's the basic things for the Vue. Well, the rest of it you don't really need to take care of it. So right, let's get started. So in the Vue, in the Three.js, well, if you wanna create a sense to use this one, you can follow the create a sense in the Three.js document. So basically, what you need is first you need a sense, and you need a camera, and you need a renderer, and then you need a function to call it recycle, make it running at least 60 times a second, or 144 times a second. Well, it depends on your monitor's flashing rate. So, right. And also, because we're going to use this module, so we need to import it to the our project. So in the common HTML, you can just use, I think you can just use something like this to import module. But since I'm using a developing framework, I have to use npm to install it. So basically, I'm going to copy it and create a terminal here and install Three. Once I installed it Three.js, I can import it everything as Three from Three. Right, that's it. And we need to create a sense. Just declare the variable for now, and a camera, and a renderer, and a control. Right, this four is the basic element for creating a 3D space by using Three.js. Let's write out comments for you. Make sure this for the basic. And we also need I think we need just a Three.js group, which is actually just like an array, but you can actually found it. You can group up a list of 3D objects in this group. Basically, you can just add it to it, just make things more organized. For now, they are all none. And for a start, we need to call up a function for initializing, which I will write up here. Okay, that's going to be our initial functions. Now, in HTML, we need some place for storaging, or let's say to make the Three.js output their pixels to that canvas. So we need to declare a container for it. So I just write up container. Right. And I need to get this container right now and get element by ID. So initial our sense. And set the background for our sense. in the 3JS, you can represent number by using 3 colors, or using a color string like red, or common way is that using the hex color, but you need to add a 0 times. I just write it on 62. That's nearly black. Also need to initial camera. We're gonna use the perspective camera, which is common cameras in the 3JS, and need to write up the we're gonna use this is to calculate the screen ratio for the camera. Well, a camera is like the camera in the real world. It's something that can transform 3D space, 3D data projected back to your screen, which is a 2D, your 2D monitor. That is actually, well, that's called a camera. Also, we're going to initiate our group, which is our IR. This a new 3 group here, and give it a name. We probably don't need this for the moment, but it's in the next step we'll probably use it for if we add roles, probably add other object, like for example a plant or car or something like that. You definitely need some group to make sure everything looks clean and clear. So right, then since add this.ir. If you worry about this when the IR added to the sense, but the IR isn't initiated, you can use this next tick, but it's only existed in the Webpack environment, so I'm not going to write it here, but just something, if anything wrong with here, you can just set up timer if not using a Webpack platform. Also, you need to add some light. This is very important. You need to have lights, otherwise you can't see anything. So light is very simple. You just new create for example, an ambient light. That's ambient light. Or if you don't want to use ambient light, you can add a point light. Well, since we want to add multiple lights, if you learned painting before, then you know that you need a multiple line to make a sense looks good. So I just copy and paste it here, save some time. And also we need a grid helper, which is you can display ground as a reference line, basically. Yeah, this is the size, and this is the divisions. This is the color of the central line. It's a little bit brighter than our background colors here. And that is the other lines. Right. Now we need to add a mesh to make sure that we have successfully created this sense. We don't want a sense that have nothing, right? So basically, well, this is purely for testing purpose. So we just add a box geometry, box buffer geometry, or box geometry, whatever. And just the size is 1, and just you need another material as well. So just get into a foam material, and we can define the colors here. There's the green colors. I think this is green, and now create a mesh. Right. So I want to stop for a second and just want to say something about this line of code. Well, basically, if you see this part, you can found that actually this is quite a standard process how you create a 3D module in the Three.js sense. So basically, you need the geometry first. That actually is I think it's array of your 3D points data, and then you need a material. So as long as you have the material and the geometry data, you can create a mesh. You can add in this geometry and material to this mesh and add it to the sense. Well, that module will appear on the sense once you've done this for step. And also, because it's a 3D space, you need the position to represent by 3 numbers, which is X, Y, and Z. In the Three.js, maybe different than the other game engines. The Y-axis is actually the vertical axis, and the X-axis and the Y-axis for the 2D screen is actually X and Z. That's a little bit different than the other game engines. Well, I think it is. Maybe I'm wrong. So, right. Now we have light, we have sense, we have camera. So, last thing we need is the renderer and the controls. So, just gonna create a new renderer. If you're using the Visual Studio like I did, you can basically found this as the grammar helper for you to write up this, to found this keyword. Gonna turn on the anti-aliases. It's basically quite standard process. You can copy all those lines from the Three.js documents. I'm basically following the Three.js document, so if you want to read through all of them, that's probably more helpful than just copying this code. Device pixel ratio and renderer set size, which is our window, the inner hide window. I think this is the inner width. This is the inner hide. By the way, because I'm making something that is full screen, so we just imported our window inner high and inner width to the renderer size. And also as well as the camera size. And if your 3D space is not full screen to the browser, then I recommend you use the containers width and containers height. Okay, since we have a renderer, and we need to import that renderer, all the data from the end renderer, and make the renderer output all the data back to our HTMLs, then we can see all those renderer result from our monitor. So I'm just going to use the append file and this renderer DOM elements. So basically, this part will return a canvas. Canvas is something in HTML, you can use canvas to draw some pictures. It's quite a free, well, just basically like the word canvas itself. and we need a control. For this, in the 3JS, we're going to use the control. They does provide some control for us. You can see here the object control, the file control, drag control, and but they all are not existing in the 3JS itself. It's only existing in the examples. So basically, if you click on examples, you search on controls, it will give you a lot of controls. Actually, I don't know this one, how to use it. So you can have a fly control and use the keyboard to control it. And you can use the drag control to drag the object. In this case, we're going to use the map control. Well, the only difference between the map control and object control is that the right click and the left click is reversed, basically. So in the map control, you use left click in your mouse to do the pen move, and use the right click on your mouse to do the object move, rotation. But in object control, they're just different. And so the map control is actually a subclass of the object control. So we need to import our controllers from, I don't know where this comes from, but yeah, don't need this. We need to import our controllers from our examples. So basically, you can use this map control, simple this, controls from 3. I don't need this one. So from 3 examples and from JSON, so I can find a folder names controls. Yes, we can find object control here. So I will import map controls from the object controls. So if you move your mouse here, you will see this. It's a class imported from the object control. Right. So map control. You notice here you don't need to write up 3 again because I already give it a name here. Right. Just check if I done anything wrong. No. Import cameras to control, and also import the DOM elements to the control. So I need to give this control some configurations rather than here than the default setting. So yeah, just copy and paste. Don't want to waste any times. Then code updates is for the first updated when you first create the sense. Now, okay. Then we need to call the function that this function is running 60 times a second. Okay. So in the Vue.js, if I want to call any variables under the method block, I need to use this update. In Vanilla.js, you don't really need this. You just write up update. Or and if you're familiar with Unreal, you probably write up tick. If you're familiar with Unity, then you probably use update. And if you're familiar with, well, any software, you can just name it. In the 3JS, actually, it recommends you to call it animate. So in here, you need to call request animation frame. That is a function that you can understand it as is signed with your monitor's refreshing rate. Or you can just write up exactly like writing just sort of like standard process to creating this a 3D sense. Don't have another way, to be honest. controls, update. So all the functions you write up under the request animation frame, it will execute 6 times a second, or maybe it depends on your monitor's refresh rate, probably 144 times or 30, or maybe more, even higher. Right. So now basically we have a sense, we have a camera, and we have lights. We have renderer, and we make it render 60 times a second, which is this one. This function will call itself 60 times, and I think we finished to create a basic sense here, but we also need to add a resize functions just for when our browser resizing. We need to call these functions to make sure that our renderer can render the appropriate amount of size, because basically sometimes your browser is not a full screen of your monitor. So basically just adding up. I just copy and paste this code, don't want to waste any time either. So but remember, you have to write this one here. So render size and update matrix, update cameras aspect, and update renderer size. That's it. I think we have created our 3D sense. Now we started to run the server and try if that works. So got some errors over here. Is that alright? This is an issue with Vue.js because because we running this callback function under the window event listener. So if I write it up this, it will point it back to the window object. That's not something we want. So we want this cameras here. So we need to write up that it's equal to this, which is in here the camera should pointing back to the Vue instance and looking for cameras object. That's problems if you're using Vanilla.js, you don't really need to worry about that. Also, I have a typo here, and that's it. And I think, yeah, we run good. Now we have a green little cube in the middle of our sense, and we can move it around or rotate it around. And see this white space, we need to adjust a little bit for our CSS. So basically, I think I should write it out here. So 0 and pending 0 as well. Right. Right. We don't have that white space anymore. Cool. So now we are starting to build our map data. So what we're gonna do is we can go to the API provided by OpenStreetMap, which is named the Overpass API. So there's a long list you can read through, but basically the Overpass API provides a tools for us to export a certain amount of data, also run their own query language in this website. So you can actually check this website, check on the query language if this is working well. So basically, I'm going to use Edinburgh City as an example here, as I live in the city right now. So I'm going to put this part as a center here, right? And in this website, you can just click on Brown, and it tell you it's big data. That's fine. That you see. Now it will help you export this building data, since we curate up the building, so it will export every single building polygons for us. So you will export a range of points data that can construct this polygon. And also, so because it's following the JSON format, so this polygon point have to list it up in a set order, whether in this orders or that orders, right? So we have this amount of data right now. What we need to do is we're going to use all these points to generate a 3D module. If you have ever used the 3D model before, 3D modeling software before, then you know that in the 3D modeling software, when you have all these points, and you can create a shape, and you can extrude the shape to become a module. So in the 3JS, we're going to have exactly the same functions to do exactly the same things. So they have a extrude buffer geometry, which is basically by using the 3Shape object. It's a object you can draw a shape in our space as a 3D object here by using very basic move to and we have a line to as well, a line to functions to draw a shape, then use that shape to extrude to a buffer geometry like this one. So see, the 3JS actually gives us an example here. So you can just create a shape, line to, line to, line to, then create a geometry, create a material, then create a mesh, add it to the sense, done. Well, here we come with the second problems. Now we know how to create a 3D module by the polygons. Now, what about the geolocation data, the points data, the latitudes and longitude? Let me export this data for you so you can see why there's a problem here. So I'm gonna export it as GeoJSON. Well, you can export it in the other formats as long as you can parse it. I'm just familiar with GeoJSON data, so I'm going to use this one. So I copied it and pasted it back to our public folder. Because the reason I put it in the public folder is because that well, this is the only place I can use Ajax functions to curate it to get it from a remote location. Just keep it at Edinburgh here and back to the space. Now we need a function to get that GeoJSON data. Just write out get GeoJSON. So if you're familiar with JavaScript, you know that we can use fetch functions for getting this GeoJSON data. Well, as long as you use anyone, you can use Ajax or you can use Axios, a lot of libraries that you can use to get a single JSON files from remote locations. So for here, we'll just write up ASX geo Edinburgh GeoJSON, and since this right, oh, I don't have a geo for this project yet, right? So then that's the result. So if the result.status is equal to 200, I think. Oh, actually, we don't actually need this because we definitely will get this GeoJSONs as we put it on our local files. So we pass as a JSON files for now, and then get this data and we call a function and we pass this data into this function to load buildings. Right. for this stage and check out if we successfully get our data. Right, there's a weird arrow, so we can ignore it for now. It's already need this one. So to call this function first, I can get a result. Right, we have get this result. So see how this GeoJSON being constructed is a they have a features array which stores the main data or the data we need, and inside it we can see this is, I think it's a single buildings, and this address the house names and house numbers and postcode, the street names and reasons, and the geometry. You can find the coordinates. It's an array that stores a range of points data. Now, about the problem I just said, this is the issue. We have this longitude, I think it's the latitudes and longitudes values, which is, you see from here and to here, it doesn't have a lot of difference. It doesn't have a great difference from the first point to a second to the last point. But back to our map, we found that it's actually this building. So the points from this point to that point, if you want to visualize it, at least you need some differences from this point to that point. At least it's 0.1 distance here or 0.6 distance here. That's something you can't really using this. This is why you can't really using these values. So how to solve this problem is that we need to normalize our latitude and longitude. By how? By what? The technique I use for visualizing this is to set up a center locations. Once you have a center location, you can calculate the distance from here to here, right? Each point from here to here, and you can get the relative locations from the central point. Then you can you can get a small numbers for represent this line. So how to get the locations that we have normalized it from coordinates we have normalized it from the center location is to calculate distance, and we draw a triangles from this point to that point, and then we know the x and y values by calculating the two edge of this triangle. Okay, since we know that we can use the relative precision to represent each point, there come with another issues. It's like, how can we calculate the distance? Well, we can't just use x and y value to calculate the distance for a map. Basically, if you set it as 0, and 0, this is probably 1. If this is the y-axis, then it probably is 1 and 5. We can't use 0 and 0 to subtract 1 and 5 to calculate the new positions for it. So or the distance. There's a issue is because our planet is basically it's a sphere. It's not a sphere, but it's a sphere. It's not a flat ground. I know some of you might disagree, but I don't care. So if you search on map projection, you found a long list of articles explaining these problems for you, because basically our planet is a sphere, so the distance between one point to another point will be affected by this. So you can read through all this article, but it just there's lots of different projection methods, and the most popular ways in building digital map is this one, the Mercator projection method. So there's one method you can
use is that use these projection methods to calculate your latitudes and longitudes to back to x and y values. And if you search on JavaScript, you will find the exact algorithms you're looking for. But for this one, we're going to use another method. That's because I tried to use that projection method. It has performance issues, so I'm going to use this one. Basically, I'm going to copy and paste the algorithm I have wrote it here. This is the algorithm we are going to use. So we are going to use a library called GeoLib library to get the distance and get the angle. So if you know this somehow, when we have a triangle here, if we know the distance and we know the angle, then we know the two edges of the two edges lengths, then we know the x and y values. That's basically how it works. And because we use the GeoLab, it allowed me to import two values, one from one latitude and longitude to another latitude and longitude, and give me back the distance, which already calculated the effect caused by the radiance of the planet. So basically, if you search on this GeoLab, you found this is actually a library allowed you to make calculations by the geodata. We're just going to install it to our project. Right, write an import everything as GeoLab from, I think the name is just named GeoLabs. Right. I'll start the servers and continue to write. I'll load buildings. Now, in the load buildings, we have imported this data, and like I say, it's an array of features. So we're going to loop the array of features. I think this data is not a features data, so I need to access the features first. So we go to data.features, and it's actually looping the features only. You don't need the rest of them. It's actually just some copyright declaration, and access each single of them. Then make sure it has property values. Otherwise, if you don't have property values, basically it is not a buildings. That's probably the point. So and since we already have the property values, we'll just directly access it. Just be aware if you use this to access property, if it's undefined, it won't stop the code. But if you're using this one, if the property value doesn't exist, then you will stop the code running. So now this time I need to access the building data. Just make sure everything we will generate is a building. So if it's a building, definitely has a building from properties. Right. If it's a building, then we will add a module as building. So we will import the features, geometry, coordinates to our add building. So it's coordinate. See if I spell it right. And also we can import the information, so we can get our building names and address, all these informations. And also if you look into the data, you will find that a lot of building contains information with levels. That means that it has the high data here. So we can also import our high data equals building levels. So then we know how tall the building will be. Now we add a building here, and now this is the most important part. So we have our points, coordinates data, we have information, we have height, which is 1 here. So now we can loop those data. So if you look into it, then those data is actually a 3-dimension coordinates. And because we already loop or access the first dimension, so we actually can think it as a 2-dimension arrays here. I'm going to loop all data inside the data, points data. You can name it as points, that probably make more sense. Also, you can use for each as well, I think. I'm just familiar with for, so yeah. Use EL to access, to represent each of them. Now back to our 3JS, we need a shape, and we need the extrude settings, and we need extrude buffer geometry, and we need the base materials, and we need a mesh. Okay. So let's get started. We need a shape. So we need to generate a shape. I'll just write a gen shape because we're gonna need a lot of calls in it. So just write another shape, generate shape. Right, in here we need a shape is equal to new 3.shape. And what we're gonna do is that we need to loop all the data inside this array, which is accessing these two figures. Oh, right, we need to import our points data. And as we know, we also need a center location as well. So we need to define a center. Right, we just use 2 numbers to represent the center. So basically you can go to any maps and you can find centers, locations by this. Right, I already got the center, so I'm just gonna copy and paste to here. Just to realize that everything goes into the GPS relative positions with 2 positions. You need to make sure that if the object position is latitude first and the longitude seconds, then the central position have to be latitude first and longitude seconds. I know from their documentations it does say you have to use objects called longitudes and longitudes, but actually you don't need to, as long as you have an array contain 2 number, that works fine. Right, so now we're looping this points data. access each of them. And yes, this one. And this is equal to, because each point is an array, contains 2 numbers in it. So I can just import it to TPS relative positions calculation algorithms here, and import our number and the center. I already imported there. And if, so be careful here, the first point to make a shape is moved to, then is line 2. So I need to write up if I equal to 0, then ELP of shape dot move to ELP 0 and ELP 1. Otherwise, shape 1 to ELP 0 and ELP 1. Right, then return this shape. Now we get a shape in here. Second things we need is a geometry. So we need another function called generate geometry as well. So we need a shape to generate it, and also we need a configuration, which is basically this part, right? So we need basically we don't need a step, we need a curve segments. Just write 1, don't make it too large, you don't actually need those. It's the building. And we need the dips. Dips is actually the height data. So I can just do this and times height, then you can see the difference from one building to another. This is actually made at the wrong corner. You don't really need those. Right. Now we need to write another functions is generate geometry here and import 2 things. One is a shape and one is a config. So right. So let geometry is equal to new 3 dot exclude buffer geometry shape and config. Also we need to calculate how big it is, set it back to self. It's for the further use. It doesn't really need to compute them for now, but I recommend you to do this. Cool. Now we return this geometry. Now we have a shape and we have a geometry. So then we can create a mesh. New 3 dot mesh here from this geometry, and we also need the material. We don't have a material yet. We can create a material right here, but because in the 3JS, if you want a better performance, you use the same material once again. You don't create materials every time. So that's a bad choice. So we're just gonna create a material here, but since our add building is also inside a loop, so we'll call it multiple times, so it probably is a bad idea. I just write it up, down in here. As a global variables, so see we can give it create a new materials here and import it to this mesh. It will optimize the performance, and we can add to the things. To be honest, we actually don't need anything. We are with the IR for now because we only have one things. Okay, I think it should work, and let's try if that's working. Well, we don't need this geometry anymore since we already have those. And get this, and yes, and nope, doesn't exist. So let's check if anything wrong. Okay, load buildings is not functions, right? I think I have a typo here. Yes, I have a typo here. I don't need to print this out anymore. Right, and refresh the page. Wow. Okay. Cool. Now we have a lot of building here, but it seems like it's not lining up on the ground because we already add up the line helper, so the reference line is the ground, and we don't have it. We'll add it to the ground. So in here we need to rotate this geometry. Rotate in X direction to 90 degrees, right? 90 degrees. So pi and 2. It says this is degrees, but actually it's radius degrees, so you have to use pi to. The pi is 180 degrees, so half of it is 90 degrees. Right, cool. We have this. It looks like everything's reversed. So we can rotate it again. Geometry dot rotate z, and pi is 180 degrees. Right, we nailed it. Now we have a 3D cities of Edinburgh right here, compares to the map right now. You can go to OSM Building. It's a website that you can see the example of how they're making it, and this is our center positions here, and this is our center position here. Okay, that's it. If you notice, there are some issues about this methods. I probably say it's a bug, because if you're looking on this, this actually is, I think it's a middle schools here. You should have a middle part, a hole in the middle of the building. They actually doesn't have one here. And also the performance is not really good if you compare with MacBooks and others platforms. You will find their performance is actually way better here. That's because you need to do some performance optimization to improve the frame rate, which I will talk about it on my next video. So yeah, that's it. I will fix this bug, and I will talk more about performance on my next video, and on my third video I also maybe talk about how to add lines, like the rows, everything.
Yeah, thank you for your patience. This is the first time I made tutorial video this long, also in English, and I know a lot of things can be improved. So I hope you did it. If you didn't, I also upload the code to online code editing platforms. There I'll put the link down the videos. So on the next video I will talk about how to improve performance, how to fix bugs, and On third video, I'll try to animate the road, so use a line to represent road, and you can animate the lines as well. And on fourth video, I'll try to talk about some user interactions, how to like click, how to build the markers that project the location from 3D to 2D. So yeah, that's it. So cool.